Hi YouTube friends, I'm teacher REGY SAFADÁO, and today we are going to talk about the trigonometric ratios and the right triangle. Are you ready? So, join us! Hi my YouTube friends, I'm teacher REGY SAFADÁO, and this is our class number 3 of 5. Let's see our opening. As we already know, this is our channel of Mathematics Without Frontiers. And here we have classes of physics, mathematics, and English in two versions. One version in Portuguese and the other version in English. All right? Very good. So let's see our today's class. It is about trigonometry in right triangles, but now we are going to talk about the trigonometric table of angles from 1 degree to 89 degrees, all right? So let's see the trigonometric table in parts from 1 degree to 10 degrees. We have here the values of the sine, cosine, and the tangent, all right? Let's see the second. From 11 to 20 degrees. Now from 21 degrees to 30 degrees. And now from 31 until 35 degrees. Let's go on. Now from 36 to 50 degrees. Then from 51 until 65. Now from 66 degrees to 80 degrees. And finally, from 81 degrees to 89 degrees, okay? So this table is going to be very important for us to solve all of those questions, word problems on trigonometric ratios, okay? So let's finally start doing some exercise. We have now to solve 6, all right? 6 questions about word problems on trigonometric ratios, okay? Let's start by the first one. See. Question 1. A cell phone satellite is at an altitude of 1,678 kilometers. Determine the distance as from this satellite to a person who used the sign of it when the angle between them is 57 degrees. Let's see. Okay, so this is a person, a user. The satellite is up there in the sky. Okay. The altitude of the satellite is 1,678 kilometers, and we want to know the distance between the satellite and the user. This is S. Okay. If you pay attention, well, let me get a laser point. I always forget this. Okay. Now having the laser point, I can point you for you better. Okay. So we want to know this distance between the satellite and the cell phone user, all right? So let's see, if you see, we have here a right triangle, okay? Okay, now you can see better, okay, in light blue, okay? And this is the right angle. The problem said that the angle between the user and the satellite is 57 degrees, we have here, and obviously, always the problem is going to give you, you don't need to memorize that table I showed you at the beginning, because the problem gives you the sine, the cosine, and the tangent of the angle of our problem. Okay, this is 57 degrees. Okay, well, we are going to use only one of them. Okay, the problem gives us the three. Okay, the three, sine, cosine, and tangent is given, but we are not to use all of them. We are going to use only one of them, or sine, or cosine, or tangent. Okay, let's check which of them we are going to use. Well, pay attention. This problem we have involves this leg of the triangle, okay, and this side of the triangle, okay. So what is this? This is the opposite side, all right? And this is the hypotenuse, you see? So what involves the opposite side and the hypotenuse? Sine, cosine, or tangent? Question number 1 is sine. Very good. So let's do it. Sine of 57 degrees is the opposite side, which is 1678, and the hypotenuse, that is S. Okay, so let's replace the sine of 57 degrees, that is here 0.839. It means that the cosine and the tangent we are not going to use. Okay, so see, replacing it is here. Now, see what we are going to do. This S here is going to be moved to the left side of the equation, multiplying this way. So we have now 0.839 times S is 1678. And now 0.839, that is multiplying, is going to be moved to the right side of the equation, dividing. So our equation becomes like this. S is 1678 divided by 0.839. So dividing it, we have that S is 2,000 kilometers. So the distance between the satellite up there in the sky and the user, the mobile user here, this distance is 2,000 kilometers. All right, so let's go to question number 2. Question number 2 is 14 meters long steel cable was attached from the ground to the top of a street lamp post. The cable forms an angle of 37 degrees with the ground. Find the distance from the cable attachment point on the ground to the base of the street lamp post. Let's see the situation. This is the street lamp post. This is the steel cable. The steel cable is 14 meters long. This is the distance we want to calculate. Okay, so it forms a right triangle. Good. The angle is 37 degrees. All of this information were given. Okay. The right triangle. Okay. And the problem also gives us the sine, the cosine, and the tangent of 37 degrees. As I told you before, we are going to use only one of them. Okay. It is necessary to guess which one of them we are going to use. Okay. So, see, let's check. We want to know X here. Okay. So this is the adjacent side. Okay. And this is the hypotenuse. Which one of them, sine, cosine, or tangent, is going to give us the answer? Okay. It's going to help us to answer this question. Well, this is the adjacent side. All right. And this is the hypotenuse. Okay. So sine, cosine, or tangent, according to their definitions, cosine. Very good. So the cosine of 37 degrees is X, okay, over 14. So let's replace the cosine of 37 is 0.799. So replacing, we have that 0.799 is X over 14, and easy. 14, that is dividing, comes to the left side of the equation, multiplying this way. You see? Now let's multiply 14 times 0.799. Okay, let's multiply this. And also, while we multiply, we are going to rotate. We are going to rotate the equation and give the answer. Okay, you see? So X is 11.19 meters. So this is the distance here between the base of the street lamp and the cable attachment point on the ground. Okay, thank you very much for paying attention to this question. Let's go to question number 3. Question number 3. The well-known Tower of Pisa in Italy, knowing that its inclination is 74 degrees in relation to the ground, determine how tall it is in meters. Let's see, the ground, the Tower of Pisa. Okay. In fact, the figures are only to illustrate our problem, okay? To put you in the situation, you see? Okay, this is the, okay. Oh, the distance is 16.34 meters. This is the distance of the base, from the base of the tower to this point here. It forms a right triangle. There is an angle of 74 degrees. The triangle is right. And sine, cosine, and tangent of 74 degrees. Let's see which of them we are going to use in our problem here. Well, the angle is here. Okay, this is the altitude, okay, of the tower. And this is an adjacent side. Okay, so which of them involves adjacent side and the opposite side? According to the definition, is tangent. Good. Okay, so tangent of 74 degrees is h over 16.34. Let's replace the values. Tangent of 74 degrees is 3.487. So 3.487 is h over 16.34. Well, this value, 16.34, which is dividing, is going to be moved to the left side of the equation, multiplying. So our equation becomes like this. 3.487 times 16.34 is h. Okay, well, now let's multiply and rotate the equation in order to give a better answer. So the answer is 57 meters. So the tower is about 57 meters tall. Okay, let's go to question number 4. Question 4. An observer placed at 100 meters far from the base of a building sees the highest point of it under an angle of 58 degrees. Determine how tall this building is. Let's illustrate the building. Okay, this is the observer. He is 100 meters far away from the base of the building. Okay, h. And okay, the angle is 58 degrees. It is right. There is a right triangle here. So this is 92 degrees. Okay, sine, cosine, and tangent. Let's check which of them we are going to use. Let's check. This is the angle of 58 degrees. And this is what? This is the adjacent side, isn't it? Very good. And what is this that we want to know? This is the opposite side. So according to the definitions of sine, cosine, and tangent, we are going to apply a tangent. Very good, because it involves the opposite side and the adjacent side. Okay, so tangent of 58 degrees is h over 100. Well, the tangent of 58 degrees is 1.600. Let's replace. 1.600 is h over 100. Well, 100 that is dividing is going to be moved to the left side of the equation, multiplying. Let's do this. So we can see that 100 times 1.600 is h. And now let's multiply and rotate. You see? So the h is 106 meters. It means that the building is 106 meters tall. Good. Let's go to question number 5. Question number 5 is, find a kite. A boy used 250 meters of thread. Knowing that the angle formed by the thread and the horizontal line is 88 degrees, and supposing the thread is completely stretched, find how high this kite is. Let's see. The little boy. The kite he is flying. Okay, this is the thread. And the problem said the thread is 250 meters long. Okay, the altitude of the kite. The angle is, 88 degrees. The right triangle. So the situation we can see here, it forms a right triangle. Okay. let's check the sine, cosine, and tangent of 88 degrees. Let's check which one we are going to use, and the others we are going to forget about them. Let's see. 88 degrees is here. This is the opposite side. All right. This is the hypotenuse. Okay, so sine, cosine, according to the definition, sine, cosine, or tangent we are going to apply here. See, opposite side, hypotenuse. It is a sine. Very good. So let's use the sine. Sine of 88 degrees is h over 250. And replacing the value of the sine of the 88 degrees, we have here 0.999. Let's replace 0.999 is h over 250. 250, that is dividing, is going to be moved to the left side, multiplying. Excellent. So 0.999 times 250 is h. Now we are going to multiply and rotate the equation like this. So the answer is 249.75 meters. This is the altitude of the kite. All right, let's see our question number 6. I mean, it is the last one. Okay, let's see. An observer is 150 meters far away from the base of a tree and sees, under an angle of 20 degrees, the exact moment that a lightning strikes its highest branch. Calculate the distance between the observer and the impact point. Okay, this is the observer. This is the tree. Okay, so the observer is 150 meters far away from the base of the tree. Oh, this is the lightning. Okay, we want to know how far the observer is for the impact point of the lightning at the highest branch of the tree. Let's see. So it forms a right triangle. We can easily see here. The angle is 20 degrees, and this is the right angle. Okay. So this is the hypotenuse. Excellent. And 150 is the adjacent side of the triangle, isn't it? Excellent. Let's check sine, cosine, and tangent of 20 degrees. We are going to apply only one of them. The others we are going to forget. Okay? Well, let's check if it is sine, cosine, or tangent according to the definitions. Okay? Well, this is hypotenuse, and this is the adjacent side, so it is a cosine. Excellent. Cosine of 20 degrees is 150 over x. Replacing cosine of 20 degrees, we have 0.939 is 150 over x. This x is going to be moved to the left side of the equation, multiplying this way. So the equation becomes 0.939 times x is 150. And now this 0.939 that is multiplying is going to be moved to the right side of the equation, dividing. So x is 150 divided by 0.939. Doing this division, we have that x is 159.74 meters. This is the answer, okay, of our question number 6. Well, my friends, thank you very much for watching our video until the end. Thank you very much, okay? Don't forget to subscribe our channel, to share this video with your classmates, your neighbors, your siblings, your parents, everybody you love, all right? And of course, give us your like. It is quite very important for us, okay? Thank you for watching our video until the end. See you. Bye-bye.
That's all, folks.